Okay, good day. So we go to pump selection method. So I have here, so you see this figure. So this is from my previous class in fluid mechanics. So this is the setup of a simple water transfer system from a storage tank. Now we have here the given temperature of water, that is 20 degrees, and the given flow rate, which is 0.6 cubic meter per second. So we will not be discussing the computation of head loss, since it is being discussed already from my previous lecture in the fluid mechanics. So if you are curious, you can go back and watch the videos that it will be in the last topic on my video on the fluid mechanics. You can check that one, so you have so that you will have a review and overview of the calculation, so how I arrive with a given calculated of total dynamic head, which is equal to 95 meters. Okay, so going back in this topic, so for the pump selection, so we have already the volume flow rate and total dynamic head. Now, the next problem is what will be the type of pump that will be used. So, dito pumapasok yung selection by means of yung pump characteristic curve. So, I have here, this side is a pump characteristic curve which is model 4013, no? 4013. So this is from the manufacturer of pump, which is the Teiko. So this is the brand, and we have the given RPM, which is, this is the RPM from the electric motor that is being produced, that is 1160 RPM. Then with the corresponding head on this axis, your y-axis, you have your head, and your x-axis, that is in the units of gallons per minute, and we have here the units of liters per second. Then we have also here, since this is head and feet, on the right side we have head in meters. Okay, this is the total dynamic head. Then we have also a corresponding head in terms of kilopascals, so pressure. So then we have also here the NPSH. So this means for net positive suction head. So later on we'll have a separate discussion for this one. So what will be the importance of knowing the net positive suction head, and how does it will affect the performance and operation of your pump after the installation. So for prolonged maintenance, so what will happen to your pump if the net positive suction is not being meet or not being calculated properly. Okay, going back, we have here your total dynamic head. If you're going to plot that one, so that is 95 meters. So you will notice the on this side, so this is in meters. So we have here, we don't have the the amount of the number of 95. So we are in the range from 25 to 0 to 20 to 25. So but we have here 60 liters. So this is if you're going to convert this one, so let's try to convert this one. So we have 1 cubic meter, so that this is equivalent to, if we have 1 cubic, that will be 1000, no? So 1000 liters, so this is divided by 1 cubic meter. Now I will going to cancel this one, so we have the value of, which is equal to 60, that will be liters per second. Now if we're going to plot that one, so I'll be using the line here, a dotted line, to represent that one. So this is somewhere here, okay, and we don't have your y-axis for your meters in head, which is, we are in the range of 25, 0 and 25. So this means that this model of pump, which is the model 403, no, the model 4013 or FI and city series is not suffice enough to deliver the requirements of your design. So this is not enough. So if you're going to select the pump, so please don't select this one. So it will give you, it will push you it will not provide you a good flow rate, and also it will not provide you the required total dynamic head. So please don't use this type of don't type this type of pump. Refer to another pump characteristic curve which will suffice your design. So maybe if you're going to install this one, it will provide you a low flow rate and low pressure discharge at the end of this pressure storage tank. Maybe it cannot reaches on this type of tank. It will not reach at this head. So this is a long piping. This is 100 meters by 5 meters with a given elevation of it is around 20 meters from the zero elevation. Now I will present here another type of pump characteristic curve. So same manufacturer I have, I will show you. Now I bring down here another model that will be 3009 with a given RPM which is 3500 RPM. So we have here the diameter of the impeller which is 9.25, 8.625, 8 inches, 7 and 6.75 inches. Okay, so we're going to plot the requirements that we have there. So that will be 60 liters per second. If we're going to see the units here, flow in gallons per minute, and we have also on the top which is liters per second. Now I'm going to draw the line here to find the type of pump that we can be used. So I have here 60 liters per second with the corresponding total dynamic head which is 95. So if you can look at here, we have 175. Okay, I just turn off my grid line there so we can interpret directly. So we have here 75. So we have here 1, 2. So we have 2, 75, 85, 95. This is somewhere here 95, and then you have here your 100. So if we try to divide this one, we can say that I'm gonna use a line here. So this is 7.5. So we have here, I'm going to zoom this one. So we have an interval that is 83.33 and 91.66. So kung paano ko nakuha yon, I have tried to, that will be right, sinolve ko nito 100, that will be minus 75. Then I will divide it by how much? So that will be 3 points. So that will be equal to 8.33. So yun yung way kung paano ko nakuha itong points na ito. Okay, so plot natin yung values. So we have your line, so this is 91, then we have your total dynamic head which is 95, no? So if we're going to plot that one, that is in between already. So plotting that one, so we have here your 95, somewhere here. Okay, so that will be your 95. Okay, so we have here the intersection. So I'm gonna write here the intersection, no, of our system. Okay, still if you see the intersection, it does not cover. So but we have here a pump which is in the range of 74.6 kilowatt at the 100 horsepower, no? So let's try another pump characteristic curve, kung kaya niya i-fit up yung requirements natin sa design o yung requirements ng system natin. So I have here another model that will be 2508. So we have here your 60. Again, if you'll notice here, again, no, So it is somewhere here, 80. We have here 80. So 80, 90. And you have your volume flow rate, which is 60 liters. So if you're going to plot that one, the intersection, so if I'm going to plot natin itong 60 liters per second, so starting from here, so we have here, I have here your 60. So 60 liters per second. Then we have 80, 90. So we have 2 points here. Also the difference. So 80, 85. You have here 90 somewhere here. Somewhere here. Okay, but still, if you're going to look that one, we have here. No? So it does not suffice yung requirement natin. So we'll try another pump characteristic curve if it kaya na siyang magamit or can be used. So from here we can but you will notice here this dotted line, it is somewhere falling beyond 100 horsepower. Now I bring down here the model 2509 at the RPM 3500, no? So let's try to plot yung requirements natin. So we have, okay, so they would have 60. So that is 60 liters per second. Then, if you're going to see, check, so this is 75. Okay, we have 2 intervals. Now, mapapansin niyo, you will notice, yung volume flow rate natin will not suffice yung requirements. But, I have here your total dynamic head if you're going to plot this one. So, mapapansin nyo, ang total dynamic head natin, which is the requirements of the system, can suffice the requirement. But the volume flow rate is not. So, that is only we have the coverage. We can plot this one. So, we have only the coverage of somewhere. So, selecting 67% efficiency, no? We can attain around 20, no? So this is 20 liters per second. So we're falling in the 65% pump efficiency. Now, so kung ganito ang setup, so dito pumapasok yung type of pump arrangement, which is yung parallel pump arrangement. So parallel type, and we have yung series pump of arrangement. So ano bang ibig sabihin nun?